Question number 116. Assertion is at anode, oxygen is obtained during electrolysis of aqueous NaCl. Aqueous NaCl is the brine solution and electrolysis results in the formation of chlorine gas at anode due to overpotential of oxygen. That's why this statement is incorrect statement. Further, if I talk about the next statement, oxygen is diamagnetic and chlorine is paramagnetic. This is also incorrect statement because here oxygen is paramagnetic due to the presence of unpaired electron while chlorine is diamagnetic. So both assertion and reason are incorrect. So which option you will choose? Definitely option 4. Let's take question number 117. Question number 117. Assertion is beryllium carbonate is kept only in atmosphere of CO2 gas. Yes, it's a correct statement because this beryllium carbonate can dissociate to form BeO and CO2. That's why it is kept in atmosphere of CO2 because beryllium has high charge to radius ratio. Due to that, it has high polarizing power and it can dissociate easily. It can decompose easily. Now, let's check the reason also. Reason states, beryllium carbonate is highly unstable and decomposes below 100 degrees Celsius. Yes, it is the correct reason why it is kept only in atmosphere of CO2. That's why both assertion and reason are correct and we'll choose option 1 as the correct option for this question. Let's take next question. Question number 118. Oxidation state of carbon in C3O2, carbon suboxide, are +2 and 0. Reason is oxidation number can be negative, positive or fractional also. So in this case, first of all, you need to just check the structure of C3O2. This is this type of structure in which central carbon is having the 0 oxidation number while these two carbon have +2 oxidation numbers. It means oxidation number of carbon in C3O2 are +2 and 0 both. That's why this is correct. But reason we need to check. Reason is oxidation number can be negative, positive or fractional. This is correct statement but it is not correctly explaining the reason why oxidation state of carbon in C3O2 are +2 and 0. It is not correctly explaining assertion oxidation state of carbon in C3O2 are +2 and 0. That's why the answer for this question becomes what? It would be option 2. After that, question number 119. Assertion is for a reversible reaction if Q is more than 1, then reaction always moves in forward reaction. To know the direction of the reaction, we compare reaction quotient Q with K, equilibrium constant, not with 1. And if Q is more than K, then definitely reaction will move in backward direction. And if Q is less than K, then reaction is moving in the forward direction. So assertion is wrong. Next, reason we need to check. Equilibrium constant is independent of temperature. That is also an incorrect statement as equilibrium constant depends on temperature. That's why for this question, option 4 is the correct option because both assertion and reason are incorrect. Let's take now question number 120. That is the last question of this discussion. Assertion is delta H for the reaction for HF and NaOH. What's that reaction? We're talking about the enthalpy of reaction. HF reacting with NaOH, formation of NaF plus H2O. This is the reaction and they are saying that enthalpy of the reaction is greater than minus 13.7 kilocalorie. It means this reaction is highly exothermic. What's the reason behind that? The reason that's given here, due to small size of fluoride ion, its hydration is highly exothermic. Yes, this is correct because fluoride ion has small size, it is extensively hydrated and due to that it results in evolution of large amount of energy, it becomes exothermic. So both assertion and reason are correct and reason is also explaining the assertion. That's why answer becomes option 1. I hope all the questions those we discussed are clear to you. All the best for your results. Thank you so much.